So let's get started. In this project we will use GPT-OSS-20B as LLM. Served by VLLM. What is VLLM? VLLM is a high-performance library for running large language models efficiently, designed to maximize GPU utilization and reduce latency. It supports features like streaming outputs, memory optimization, and multi-GPU inference to accelerate model deployment at scale. I start by creating a folder I call VLLM server, where I will set up the VLLM server. I use Docker to start the server. So I create the Docker Compose file for that. If you are not familiar with Docker, you may want to check my other videos on how and why working with Docker. The link will pop up now. In the Docker Compose file, we need to configure the container where VLLM will be running. For that we have to first declare a service. Let's call it VLLM. Then we specify the base image we will use. On Docker Hub, there is a base container prepared for running GPT-OSS. I have good experience with this image, so I am going to search for that. Let's open the browser and search for Docker Hub. In Docker Hub, let's search for VLLM/VLLM OpenAI. We select the first result. Navigate to the Tags tab and search for GPT-OSS. Then I will just copy the name of this image and paste it in my Docker Compose file like so. Then I give the container a name. Let's call it VLLM GPT-OSS. Next we define the command to be run each time the container is started. This container will only be for running VLLM. The Docker image is configured so that the entry point runs VLLM serve. So all we need is to specify the model name, in this case OpenAI/GPT-OSS-20B. Then we fix the GPU utilization to 95%. This is to make sure the model never uses the complete VRAM, as we may want to compute some other stuff on the same GPU. I am going to use a single GPU A100 for this application, as it is enough to run GPT-OSS-20B. Next we need to specify the download directory, where the model weights should be loaded. This is important, so we just download the model once, and store them persistently on our system. I will first create the folder to store the weights. Let's call it models. Then I specify /models as download directory. Next we define the port to expose the endpoint. We also disable the prefix caching to avoid memory overloading. Then we set the shared memory size to 64 GB. Ensuring that large tensors and parallel processes, like PyTorch data loaders, or attention backends, have enough memory space to work properly. Then some limits. These hyperparameters are important to control the memory usage. Next step is to specify the device. We want the Docker container to use NVIDIA as runtime. That is why we set the driver to NVIDIA. Then we can also set a fixed device by giving its ID. This is for the case you work on a server with many GPUs available. The capabilities is a list with GPU as item. Then, in order to make the models folder visible in our Docker container, we need to mount it to the container. You do this by using the key volumes in the Docker Compose file. Its value is a list. But we only want to mount one element. You give the path of the folder or file you want to mount, in our case the folder models we just created. Then followed by a semicolon, you give the path where you want this folder or file to be accessible inside the container. We want it to have the same name. And also the same name we specified as download dar of the VLLM command. Then we map the ports. We want to map the port 8008 of the container to the port 8008 of the host. On my system I am not able to run GPTOSS if I don't use Triton as VLLM attention backend. So I have to set this like so as well. So it looks good and we have the Docker Compose file ready to use. But before we build it, we need to install Hugging Face CLI, as the VLLM container logs into Hugging Face to download the model weights. And to install Hugging Face CLI we need Python. So let's first install Python. Done. Let us clear the terminal. Let's now install the Hugging Face CLI. It fails. Let us clear the terminal again and try to install in a virtual environment. I do it by running python 3-mvenv. You see the folder has been created, with bin and activate in it. Let us activate the virtual environment now by running source venv bin/activate. Then you will see this venv at the beginning of the command line, meaning that we are now working in the virtual environment. Now let us start the Hugging Face installation again. Now it works. The Hugging Face CLI has been installed successfully and we can now use it to log in. We clear the terminal first. Then with Hugging Face CLI login we log in. We are prompted to enter our token. I have one, so I will just copy and paste it here. If you don't have a token, then register to Hugging Face and request one. The login was successful, so my Docker Compose should work. Let us deactivate the virtual environment and navigate to the folder where we have the Docker Compose.yml file. Here you can see that we are now in the VLLM server folder. Let us clear the terminal. Then by running docker compose up-d, we can build and start the container. We have a bug, the ports key expects a list. Let's fix it. We need to add a white space here. Let's retry the docker compose up-d command. Now the container VLLM GPT OSS has been created successfully, as well as a default network. It can take some time as it is the first time I am downloading the weights of GPT OSS 20b. To watch the state of the container while it is running, we can run watch-n1 to say we want the logs to be refreshed each second, and then followed by docker compose logs VLLM, the name of the service we specified during the creation in our docker compose file. You can see that the folder models/OpenAI/GPT OSS 20b has been created and the model checkpoints are being downloaded. This video is a snippet from one of my videos in the series where I build an AI agent application in 7 days. If you want to learn more, check the link to the full video in the description below. Do you prefer short segments like this? Let me know in the comments. And don't forget to like, share, and subscribe so you don't miss my upcoming uploads. See you in the next one, and until then, happy coding and debugging with K-Tips.